I Welcome to 9.1 Exponent.
All right, today we're talking about exponents. So we're going to be able to write expressions in exponential form, identify the base of an expression or an expression in exponential form, identify the exponent and the power of an expression in exponential form. All right, so here we go. So when we're looking at repeated multiplication, we're looking at different types of problems with repeated multiplication, and we're looking at how we can shorten that up. So let's look at this real-life problem where we have a scientist who observed the hourly growth of bacteria and recorded his observations. So when there were 0 hours, there was 1 bacteria. In 1 hour, there were 2 bacteria. In 2 hours, there were 2 times 2 bacteria, which was 4. In 3 hours, there was 2 times 2 times 2 bacteria, which was 8. In 4 hours, there was 2 times 2 times 2 times 2 bacteria, which was 16. So when we completed the table, what patterns did we see in the total of bacteria column? Well, you should have noticed, so it went from 1 to 2 to 4 to 8 to 16. So what we should have noticed is that the next answer is always times 2 of the answer before it. So 2 is times 2 of 1, 4 is times 2 of 2, and so on and so forth. So essentially the next one is always double of the last one. Then we can look and notice that there's a pattern when it comes to the number of hours. So if you look at the hours, so at 2 hours, the total equals the product of 2 2's. So at 2 hours, 2 times 2 is 4, and that was the answer. At 3 hours, the answer was 8. Well, if you look at the product, there's 1, 2, 3 threes. So there's 3 hours, and there are 1, 2, 3 threes. And you'll notice that that is also the case for 4. When there were 4 hours, there was 1, 2, 3, 4 fours. All right? So how do we make this smaller? Because we don't want, think about this. He could have watched this for 10, 20, 30, 40. He could have watched this for days on end. And we don't want to have all these times 2, times 2, times 2. So how can we shorten this when it comes to repeated multiplication? All right, so how is the time in hours related to the number of times 2 is used as a factor? So how is the number of hours related to the number of times we see the number of 2 multiplied? So again, when we have 4 hours, the number 2 was multiplied 4 times. So the number of hours is the number of times the factor of 2 is repeated. So for example, if there are 2 hours, there are 2 2's being multiplied. All right, so when you're writing a number in exponential form, what we're doing is we're taking that repeated multiplication and we're making it smaller. So instead of writing this 3 times 3 times 3 times 3 times 3 in this long drawn out expression, what we're going to do is we're going to count how many 3's we have. So I have a little helper here and she's going to help me count. So we're going to count. So that's 1,
2, 3, 4, 5.
So I have 5 3's. So that tells me that I'm multiplying the number 3 5 times. So what I'm going to do is 3 is going to be my base because that's the number being multiplied. And then since it's being multiplied 5 times, because we said 1, 2, 3, 4, 5, 5 is going to be my exponent. So my exponential form is going to be 3 to the 5th power, where 3 is my base. And 5 is not my power. 5 is the exponent. Okay, 5 is the exponent, and that is really large font. Let me make that a little smaller for you. Okay, so 5 is the exponent. All right, now what happens when that base number that's being multiplied is a fraction? Nothing. It's exactly the same. So we do the same thing. We count how many times we see that number. All right, little helper, help me out.
1, 2, 3, 4.
All right, so we see 4/5 4 times. So my base is going to be, say 4/5.
4/5.
So my base is going to be 4/5 and my exponent is going to be
4.
That's right. Look at that. Okay, so my base is 4/5 and my exponent is going to be 4. Okay, again, 4/5 is my base. Now the whole thing, the 4/5 is the base, and then the 4 is the exponent. All right. So taking it when it's in repeated multiplication and changing it to exponential form, that typically is pretty easy for students to do. It's confusing when we take it out of exponential form because we forget that we're repeating the multiplication. All right, so I want you to go ahead and I want you to take a minute to try these problems on your own. Pause, and when you come back, we'll check your answers. All right, so for the first one, you should have had a base of 4 and an exponent of 3. For 3, you should have had a base of 6 and an exponent of 1. For number 1, you should have had a base of 1/8 and an exponent of 2. And for number 5, you should have had a base of 5 and an exponent of 6. Now, I did not tell you in the last one, and I should have, that when you have a fraction and the whole thing is being multiplied, you have to put the parentheses around it. If I were to have written it like this, so if I would have just written let's see, with the squared above the 1, then it looks like just the 1 is squared and not the 8. Because it's the 1/8 that's being multiplied twice, you have to put the parentheses around the 1/8 so that way everybody knows that it's the 1/8 that's being squared, not just the 1. Okay, so no. Yeah, oh, yes. All right, finding the value of a power of 0. So when you have 5 to the 0 power, your answer is always 1. Okay? So anytime you see 5 to the 0, your answer is always 1. Another common occurrence is seeing just a number like we saw before. Anytime you see a number with no exponent, in theory, there is an exponent there, and that exponent is the number 1. So if you see 5 to the first, that means 5. Or if you see 5, that can be written as or means 5 to the first power. Okay? But 5 to the 0, or anything to the 0 power, automatically gives you 1. Because it means you have 0 5s. And there's a whole lot more that goes with it. We're not going to get into that right now, so just trust me that it works. That 5 to the 0 power is 1. All right. So find the value of each power. So when you're finding the value of the power, now remember, the power essentially is the answer to the exponential problem. Okay, so 10 to the 4th power is not 10 times 4. 10 to the 4th power means that we're taking 10 and we're multiplying it 4 times. So we do 10 times 10 times 10 times 10, which we know we can shortcut, and all these ones multiplied together is 1, and then there's 4 zeros. So the power in this would be 10,000. So the value of the power is 10,000. So again, if I write this as an equation, so if I did 10 to the 4th power equals 10,000, and I'll write the 4th power up here, don't worry. All right, so I know that we say to the fourth power, but that doesn't make it the power. So you have to remember that this is the power, this is the exponent, and this is the base. And here we can even color code it. So base 10 is the base because that's what's being multiplied. That's the factor. The power or the solution is okay, so the power is the answer or what you get after you solve it, and the exponent is how many times you're multiplying. So in this case, you have 4/10 to the third power, so you're multiplying 4/10 times 4/10 times 4/10. When you do that, now remember, you can easily say 4 times 4 is 16, times 4 is 64, but then you have to move the decimal. So I get 64, but then I have 1, 2, 3 numbers after the decimal, so I have to move my decimal 1, 2, 3 places to the left. So my answer is 0 and 64 thousandths. Now look at this. We have a 0 power here, and it's a fraction. Don't let that fool you. Anything to the 0 power equals
1.
Good job. Look at that. Easy as pie, right?
Right.
Anything to the 0 power equals 1. Now we have 2/3 squared. This is where you have to remember how to multiply fractions. So you have to do 2/3 times 2/3. Remember, you multiply across the top and across the bottom, so you would get 4/9. Okay. Again, that's why I said you have to have the parentheses around the outside, because otherwise you would have gotten 4/3, because you would, if it was just connected to the 2, you would have only done 2 times 2 and you wouldn't have done 3 times 3. So you have to pay close attention to what's actually being squared. If there are parentheses around this, the fraction is being squared. If not, only the numerator is being squared, or maybe only the denominator is being squared, depending on where that exponent is, or what that exponent is. All right, so I want you to take a minute, and I want you to not only find the value, I want you to write down what's actually happening. So like 3 to the 4th power would actually be 3 times 3 times 3 times 3. Okay? Just so we can get in that habit and practice. And remember, it's not 3 times 4. And 3 times 3 times 3 times 3 is not 12. Because 3 times 3 is 9. 9 times, and that's what you get. Okay, so and then 9 times 3 is 27. And then 27 times 3 is 81. So 3 to the 4th power is actually 81. All right, so take a minute and pause. And then when you come back, we'll go over your answers. All right, so here you should have gotten 1 times 1 times 1, and you were going to do this 9 times. So that's 3, 4, 5, 6, 7, 8, 9. I have copy and paste, so I probably did it a little quicker than you got to. And then here, and no matter what, so 1 to any power is also going to be 1, because no matter how many times you multiply it, you get 1. Okay, here you have 2/5, so it'd have been 2/5 times 2/5. You probably get to write this one a lot faster than I did, though. Times 2/5. And then when you do 2 times 2 times 2, you get 8, because 2 times 2 is 4, times 2 is 8. 5 times 5 is 25, times 5 is 125. Okay, I bet you a lot of people are making that mistake of saying that this was 6 and this was 15. You can't get in that habit. Remember, you have to treat it just like you would an expression. 2 times 2 is 4. You take that answer and multiply it by 2, which is 8. And then this one would have been 12 times 12. And 12 times 12 is 144. All right. All I'm asking you to do now is complete your guided practice. All right. And as always, if you have any questions, please be sure to email me or write them down so we can go over them in class. Thank you, helper.
You're welcome.